Have problem 10-77. It says, on graph paper, sketch the parabola that is the set of all points equidistant from the focus 0, 7 and the directrix y, -3. So I got out my graph paper, and I know that the directrix was y, -3, and I know that a parabola is the set of all points that's equidistant between the focus and the directrix. So they told me they gave me the focus, they gave me the directrix. So that tells me that the vertex must be equidistant, between the focus and the directrix. So I just counted, that's 3 and 7, so there's 10. So I just counted up from here by half of 10 is 5, and I got my vertex. And that having the vertex helps me with the equation and graphing form. So the vertex gives me h and k. So now I know that h is 0 and k is 2. And then remember there's a. It's the stretch factor. But then we found out that a was 1 over 4c, or some books say some books call it p and some books call it c. Ours calls it c. C is the distance from the vertex to the focus. Well, I can look at what I've drawn so far. Since they gave me a directrix and a focus, I was able to find the vertex. And now that I have the vertex, I can just count what C is. C is the distance from the vertex to the focus. So it's 1, 2, 3, 4, 5. So C is 5. So I just plugged C in, and that gave me 1 over 20. Okay, so that's where I got this, and because they told me to graph it, so I graphed it I just plotted a couple points. I thought 2 would be a nice number to plug in there because the 4, like 2 squared is 4, and 4 can cancel out with 20, and it gives me 1/5 plus 2, so that's 2 1/5, so that gave me an ordered pair right there. And then I know there's one on the other side because there's a line of symmetry here. But then I felt like I wanted just one more point. So I tried 4 because I thought, 16/20 I could reduce that to 4/5. So that just gave me a rough sketch. But then on letter A, it says, use the definition to write and simplify the equation of the parabola. Well, I mean, I've already got the equation of the parabola, but I'm supposed to use the definition. So the definition says that a parabola is the set of all points that are equidistant from the focus to the directrix. So distance 1 is equal to distance 2. It doesn't look like it because I didn't draw it very nicely. This one looks more like it, right? More equidistant. So what I have to do is use my distance formula, and I'm going to just call that, well, I can use any point. I can use this one or this one, any point on my parabola. So I'm just going to get a random point, and I'm going to call it xy. Okay, and then I'm going to use the distance formula. The distance formula between 2 points is you can get the difference of the x's and square it, plus the difference of the y's and square it, and take the square root, and that's because of Pythagorean theorem. So in other words, if I want to use the distance formula to find out the length of this see how I can make a triangle, and this is a hypotenuse right here of a triangle. So I can go a squared plus b squared equals c squared. Well, this distance right here is just the difference between the y coordinates, and this is just the difference between the x coordinates. But when I go a squared plus b squared equals c squared, if I want to get c by itself, I square root. So I get c is, right, but a is the difference between the I don't know, it doesn't matter if you put A first and B second or B first and A second. But these are both the two legs of the triangle, and one comes from the difference between the x coordinates, and the other one is the distance between, or the difference between the y coordinates. So I'm going to use that fact to set up this equation. So, and I'll do it over here. So this one distance is going to be the difference of the x's. So what's the difference of my x's? It's going to be x2 minus x1. Well, I mean, I can call it x2 if I want to. But x minus 0 is just x. Okay, and then the y's, it's y2 minus y1, but the difference between the y's is just y minus 7, and that's equal to the different, this piece right here. And so this piece, interestingly enough, see how I have the directrix is -3? 1, 2, 3. So it's going to be whatever the y is. See how the y is the distance up from the x-axis? That's what y is going to be. And then I have to add 3 to it, because when we find this distance, we have to go straight down, or it could be this distance. Any distance from on the parabola to the directrix is going to be a vertical distance. So it's going to just be y plus 3, because this 3 right here. So that's why we have y plus 3 over here. These two distances are the same. So then I just did some algebra here. I squared both sides. Here, I'll show it. And I also squared inside here. So this is a binomial. So when I square it, I get y squared, and then I get the first thing plus the second thing times 2. And then I square the second thing. Okay, so I squared it all out. The square root disappeared because I squared both sides. This one, when I squared, I got y squared, and then that times 2 is 6y, 9. And then I went through and I said, well, they both have y's, so I'm going to cancel those out. I want to try to get it into graphing form, so it looks like I just subtracted 6y on both sides. That gave me the 20. And I looked at it and I said, oh, well, I think I'll subtract 49 on both sides, and that gave me the -40 over here. And then if I divide everything by -20, then I come up with my parabola in graphing form. And then letter B says, change the equation of this parabola to shift the graph 5 units to the right. So this one doesn't, you know how it's x minus h plus k? So they're saying shift it to the right, so I'd have to put a 5 in there. So that's where that came from.